Measure function. Period, frequency and amplitude are selected for channel 1. The oscilloscope provides a total of 30 parameters for auto measurement. By pressing the Show button and selecting channel 1, all 30 parameters for channel 1 are displayed. There's no signal at channel 2, so there are no values on channel 2. The selected parameters can be deselected individually for the selected channel 1 with the Remove function. Alternatively, all parameters can be quickly removed with the Remove All function. The Acquire function. The sample mode is standard. Before using the scope for the first time, it is important to make a probe compensation. The probe is connected to channel 1. Connect the probe to the compensation connection. Use the delivered screwdriver of the accessories to calibrate the BNC connector of the probe. The over and under compensation is shown on the display. Now the compensation is correct. Let's have a look to the function buttons and press the first button, Utility. The function menu opens. The positions can be chosen with the multifunction buttons. Different languages can be chosen. Let's keep English here. The key lock button locks the oscilloscope. The device now ignores further inputs. To unlock the device, press the menu and force buttons in the trigger sections 3 times. Now the device is unlocked again. Device changes the USB connection for PC rear and USB stick front side. About shows the actual software version. Now select Display. Backlight changes the brightness of the display. Reticule changes the reticule appearance. Menu time specifies the length of the time after which a window in the display is closed. Now select Adjust. To obtain most accurate measurement values, the device can be self-calibrated. Remove the probes and press Self-Calibration. The oscilloscope is calibrated. This process takes some seconds. The default button resets the device to the factory settings. The last option in Adjust is Probe Check. Connect the probe to the BNC connector. And press the Probe Channel button. The probe is measured. And the result is good. We calibrated the probe well in the previous step. We switch to the section Save. The device can save different types: waveforms, configuration and images. We start with configuration and setting 1. When pressing Save, setting 1 is saved. Now we change the parameter for the signal and press Save again. Now let us load the saved configuration. Setting 1 is selected. Setting 1 is loaded now. Setting 2 is loaded for comparison. The old configuration is restored. In the next step, we want to save images on the USB stick. The USB stick is plugged and the USB symbol appears in the upper right display. After pressing save, the file name, here BMP and O, can be set. After setting the file name, return is clicked. The saving to the USB stick takes some seconds. Saving can also be done using the shortcut key copy. A file name, here BMP1, is selected and return is clicked. The BMP1 file is saved on the USB stick. Data can also be saved as TXT or CSV files for evaluations on the USB stick. Select waveform external as the storage and TXT as the file format. Press the shortcut button copy to save. Data o.txt is selected as the file name. The image should also be saved as a CSV file. For this, CSV is chosen. The shortcut copy button is pressed. A file name is chosen and the CSV file is written to the USB stick. On the USB stick, the files BMP0 and BMP1 can be chosen. The files can be opened and edited as bitmaps on the PC. The data were also saved as CSV and TXT files and can be opened with the text editor. You can see 10,000 data entries. You can see the difference in voltage and time. Let's close the windows. The Auto Set button quickly sets the oscilloscope parameters back to their default values. The Run Stop button freezes images and enables them again. The trigger must be deactivated for this. And displays evenly spaced data points. The peak detect mode emphasizes outlying data points. The average mode shows each point averaged over the last n captures. With type, the representation can be selected as vector or dot. With persistence, the display duration for the vectors or dots is set. In XY mode, you can display LISA use figures. The persistence is set to 5 seconds. A line is created parallel to the x-axis. Now the second channel 2 is switched on. The XY mode is selected again. The result is a straight line with a rise. The vertical gain of channel 1 and 2 are set to the same values. Now a straight line is created at an angle of 45 degrees. The cursor function is used to measure voltage in time. You can select time, time and voltage, and auto cursor and voltage again. The measurement lines can be changed with the multi-purpose knob. The change between the measuring lines takes place with the parameter line. Line A selects the first, line B the second, and line AB selects both lines. The result is displayed in the lower left box. Now the type time is selected. The first line is chosen and positioned. And the second line B selected and the process repeated. With AB, both lines can be moved at the same time. In the time and voltage type mode, 4 line pairs for time and voltage can be positioned simultaneously. The auto cursor mode is similar to time voltage. In contrast, the oscilloscope chooses which value is measured first. Of course, a measurement can only be carried out if a probe is connected. The trigger menu button selects the trigger system. The trigger level rotary knob sets the trigger voltage. Single monitors one channel for triggering and alternate monitors both channels. A distinction is made between edge and video for the trigger signal. When selected video, you can choose between the different video formats NTSC, PAL and CCAM. The trigger signal distinguishes between auto, normal and single. Coupling is supported for DC and AC. A rising or falling edge can be selected. Hold off defines a dead phase during trigger time. Time is reset with hold off reset. Force generates a trigger signal in normal and single modes. With a math function, mathematical operations can be applied to the signal. Another signal is required for the test. Two signals from channel 1 and channel 2 are aligned with one another. The math function is opened by pressing the gray math button. A third signal is generated on the display. The signal is the sum of channel 1 and channel 2. Total because the plus symbol is selected under sign. The minus operation is chosen. A straight line is created at 0 point. The other operations, multiplications and divisions are tested. The top signal changes. A great feature is that when you press the button, the default position is set. The type FFT fast Fourier transformation is tested. The two input signals from channel 1 and channel 2 are shown on the time axis in their upper display. In the lower display the signal from channel 1 in the frequency domain. The math mode is exited by pressing the math button. The channel 2 is deactivated. The channel 1 signal is automatically aligned by pressing position button. The oscilloscope is connected to the PC. The oscilloscope must be selected via utility. Here, PC is set. The software will start. A continuous data stream is selected in the communication menu with Continue Data Download. The signal from the oscilloscope is displayed in the software. As soon as the display of the signal on the oscilloscope is changed, the display in the software changes. The signal can be further processed on the PC with additional software.